Hi guys, Patrick here with goldkilns.us. We're out here in the garage today. This is the next step of our ore concentration and firing. And over here on this table we got a whole bunch of stuff set up. And we kind of go through it here. Basically, we started with this rock that is a high-grade sulfide ore that's multiple ounces of gold per ton. We run it through a crusher and then we concentrated it with a little miller table, and we got to this step, and then we roasted our ore. We reconcentrated again on the miller table, a different process, and this is our ore after we've crushed it, concentrated, roasted it, and we're just ready to put it into the crucible to do a crucible fusion using a litharge flux. I took our ore samples and I went over here and I used this mortar and pestle right here, and I ground our ore sample down to where it goes through this screen right here. This screen's about a 50 mesh. That one down there is a 50 mesh. And anyhow, I threw it in that mortar and pestle and ground it up to where 100% of it went through that 50 mesh screen. You want it as fine as you can. If you were doing a fire assay, typically they go to 100 mesh, but that's not where we're at with this little setup. We'll use, once again, we'll put our material in this clay, this fire clay crucible, DFC 40-gram crucible. We'll mix all of our ore with our flux here. And I'll reset the camera up when I go to mix all this stuff up so you get a little better idea of what's going on. We have a litharge flux, lead oxide PbO, anhydrous borax, Na2B407, sodium carbonate, which is commonly called soda ash, silica sand, and flour. And at any rate, we'll run a crucible fusion using the KK8, and then we'll pour into this conical mold here. This is a graphite double conical mold. A lot of people use cast iron, and I used cast iron for a long time, but I prefer these graphite ones. I've still got a cast iron one. I use it for a doorstop. And once we run our crucible fusion, we'll pour into there. We'll end up with a lead prill similar to this one. This one here weighs about 27-28 grams, and that's what we're going to try for. And once we get it into a lead prill, we'll put it in a cupel. This is a large cupel, Maybor cupel, that fits in the cupelling kiln over here, which is a modified KK6 with the ring and everything. We'll put our cupel in there, we'll cupel it off, and we should end up with a big bead of gold in the bottom of it all. So flux recipes, everybody's got their own flux recipes that they like, including me. I've got a lot of notes on a lot of it here that I've worked with over the years and everything. And this is a little book that I wrote about using a microwave to do fire assays. I thought about melting this in a microwave rather than using the KK8, but I decided that it'd take a longer, more explanation that we need at this point, because basically what we really want to show here is that we want to go from this rock to this concentrate, and then from that concentrate into a bead of gold, and ultimately that's where we're going to end up. So I will set this camera up on the tripod so you don't have to watch me swinging it all over the place and getting dizzy and everything, and I'll focus in on this area here where the scale is, and I'll talk about using the litharge, the lead oxide, the anhydrous borax, the soda ash, sodium carbonate, silica sand, and flour. And I'll try and make some sense out of this without making a real lengthy explanation. And then we'll move the KK8 out and we'll do our crucible fusion. We'll pour into that double conical mold. We'll get a lead prill, and then the next step is that we'll Q-pellet off. So having said all that, let me set the camera up and I'll get back to you. Hang on. Okay guys, I'm back. This is where the rubber meets the road. Well, like I said, there are as many flux recipes out there as there are stars in the sky. Everybody has their favorite, and I've got some of my favorites. And let's start with this material right here, this orange material right here. This is the high litharge flux. Contains a high amount of lead oxide in it, and smaller amounts of the other components that will add to it. And what I do is I just take this high litharge flux and then I add whatever components I want to match my flux recipe. This litharge flux here runs 70% lead oxide, 23% sodium carbonate, 4.5% anhydrous borax, which is super low, and SiO2, which is silica sand, at 2%. So it's really starved on the bottom end of it, but it's real high on the litharge end of it. And so what that does is that allows me to adjust the flux to whatever mixture and recipe that I need. I typically work with 15 grams at a time, but in this fusion here, we're going to work with 30 grams. So I'm looking for 140 grams of litharge, 60 grams of sodium carbonate, 36 grams of anhydrous borax, and 20 grams of silica. So in order to get that, we're going to start using basically 200 gram increments here, based on what's in the flux. So I'll take this spoon here in this flux and I'll add it to this little scale in this little pan here, and I'll shoot for 100 grams each time. Now when you say, oh wow, that's a lot of litharge, well yeah, it is a lot of lead, but then again, we're only going to add enough carbonate material to precipitate about a 30 gram lead prill. There's 100 grams. These little funnels are invaluable. So there's 100 grams, which would be 70 grams of litharge in there, 70 grams of lead oxide. And we'll scoop some more in here and shoot for another 100. Stuff's heavy, obviously, lead oxide. So 100 grams of this material don't look like a whole hell of a lot. Okay, there we are. Okay, so now at that point I got my litharge in there. Now I want to add my ore, which is we've roasted and concentrated, and I'm looking for 30 grams of this material, which is just almost everything that's in that little dish. 29.5. $30. Okay. 30 grams of ore. That's where our goodies are. Now, sodium carbonate, which is more commonly called soda ash, according to my mixture, in order to get the amount of soda ash that I need to add 14 grams of soda ash to come up with a total of 60 grams. So I'm looking for 14 grams. There's the 14, so that gives us a total of 60 grams of sodium carbonate and a CO3. Now, borax. I'm looking for a total of 36 grams. And like I said, this is way anhydrous borax starved. So I have to add 27 grams of borax in order to come up with a total of 36 grams, because that flux is way starved on anhydrous borax. And sometimes I got to think about what I'm doing because I can't walk and chew gum at the same time. Okay, there's the borax. Now silica sand, SiO2, I need to add 15.6 grams. And silica is pretty dense, so it's not going to amount to a whole heck of a lot in here. 15.6. Each one of these components performs its own little role during the crucible fusion, and each one of them are very important. So that's the constituents of our flux right there. That's what's going to go into our 40-gram crucible, into the furnace, the KK8. Now, we have 140 grams of lead in there. But we don't want a 140-gram lead prill. We only want about a 30-grammer. So we add a reducing agent. A reducing agent that we're going to add at this point will be flour. What happens in that crucible fusion is you add a given amount of a carbon source to the crucible fusion, and flour, or whatever your carbon source is, tries to burn inside of that oxygen-free environment inside of the crucible. The only way it can burn is to steal oxygen atoms from something that's in there. And basically what it will do is it's going to steal oxygen atoms away from the lead oxide. When the oxygen atoms are removed from the lead oxide, it becomes metallic lead. The metallic lead will rain through the column of ore, dissolve the gold into it, and collect in the bottom of your crucible. When you pour it into your conical shaped mold, all of the metallic lead, such as this little prill here, ends up in the bottom, and that's where your goodies are. So there's different reducing power of different things. Now this started out as an arsenopyrite. We roasted the ore to get rid of the pyrite and the arsenic. Each one of those is a reducer in itself. Iron pyrite will reduce 11 grams approximately of lead oxide for every 1 gram of iron pyrite, because it is a reducing agent. Arsenopyrite, let's see if I can find it here, also reduces lead at a less rate. Yeah, arsenopyrite will reduce approximately 4 grams of lead oxide to metallic lead per gram of arsenopyrite. Now what we did when we roasted our ore was we added a little bit of charcoal to it while we were roasting it to reduce any excess amount of arsenic that wasn't driven off the initial roasting spot, the roasting process, to another arsenic compound, and then we vaporize it off to get rid of all the arsenopyrite. Arsenopyrite, arsenic end, it really causes a lot of trouble in your fire assays. So we got rid of that. So we may have a small amount of iron pyrite if we didn't get a complete roast, which I believe that we did, as well as I believe we got rid of all of the charcoal by ashing it and burning it off. Charcoal reduces lead oxide at a real high rate, 18 to 25 grams of lead oxide per gram of charcoal. So here's where we're at. Trying to control that lead prill is really, really difficult. And if you have any extenuating circumstances, say you got a little bit of pyrite, a little bit of arsenic pyrite, the arsenopyrite left, or a little charcoal left, it'll reduce more of the lead oxide than the carbon source that we're going to put in. But we can stand that because we got a great big cupel here. So theoretically at this point I believe our oxidation is complete. I believe we drove all of the arsenic away, and so I'm going to add enough flour at the rate of 1 gram of flour will reduce 11 grams of lead oxide to metallic lead. So I'm going to add basically 2.7 grams of flour, which would give us 29.7 grams of lead oxide. It's like I said, this can kind of get complex, but I did write a little book about doing this with a microwave oven for the crucible fusion. And right now I know that's a little bit, that's it. Here I am trying to talk and not paying attention to what I'm doing. I'm way overboard there, so I'm going to have to switch. Like I said, I can't walk and chew gum at the same time. I'm looking for 2.7 grams of flour. And that's like twice as much as I need. 2.8. We'll call it 2.8. That's close enough for me. That will theoretically give us 29.7 gram lead prill. So we got all of our flux components mixed in there. And now that we have all of our flux components, we have 30 grams of ore in it, etc., etc. We'll put the lid on our jar, and then we mix everything thoroughly. And the best way to mix everything, as you can see the colors kind of showing up, is to roll your jar. And what that does is that distributes everything evenly and homogeneous in your crucible when you pour that into our crucible here. So we have all the components mixed, and we're just simply mixing them all together so that everything is homogeneous, and we put the heat to it. The flour starts to burn, steals oxygen molecules away from the lead oxide. which is in contact with the ore that's got the gold in it. The gold dissolves into it and drops to the bottom. But anyhow, getting back what I was saying there was I did write a little book once upon a time about using a microwave oven to do a fire assay, as well as using the little cupel kiln, the little quick kiln cupel kiln to cupel it off. Whether you choose to use a microwave, which I'll probably do a video using a microwave to do just exactly what we're doing here, but use a microwave rather than a KK8 and everything. There's a lot of information in there that explains the whole process about what the crucible fusion does, how to cupel, how it converts the lead, metallic lead, back to a lead oxide, which gets absorbed by the cupel, and lots of flux recipes. So if you're really interested in learning how to do this and you don't know how, the little book will give you a whole heck of a lot of information. I could talk for hours just about what each individual flux component does in the crucible fusion and why you need it, but then again, we don't have hours, and besides that, it gets boring. So having said that, where we're at right now is we have our ore, our flux components, and everything is all ready to go into the crucible, which we will put into the KK8 at, we'll start out around 1500 degrees until everything gets settled down in the crucible, and then we'll raise the temperature up to about 1950 and hold it there. This is a 40 gram DFC ceramics fire clay crucible. I build these little lids, and I put that little lid on there while it's in the furnace to keep it from spattering, etc., 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 etc. So, having said that, we went through the steps, took our ore, crushed it, concentrated it. We ended up with this. We roasted it, concentrated it again, ended up with this material. We just took 30 grams of that material, mixed it with all of our flux components, and mixed them all together along with the flour necessary to produce a lead prill of approximately 30 grams. And there is our lead prill. So next thing I need to do is I need to set up the KK8. I'll get it set up. We'll pour this into the crucible. We'll put our lid on the crucible. We'll put it in the furnace. We'll run it up to around 1600 degrees until everything settles down for a little bit. Then we'll increase the heat up to about 1950, and we'll hold it there for a while, and then we'll pour our mixture into this little conical shaped mold, and then when we flip it over and everything, break the flux away, we'll end up with a lead prill similar to this that should have a lot of gold in it. That's what I'm hoping for, and I'll get this stuff set up, get the camera set up, and we'll take off and we'll go do it. Hang on, I'll get back to you.